Alrighty, happy Friday, everybody. We are going to go ahead and complete our lesson on simplifying radicals today. Then you will take your CFA on special products, and then you will start your homework. So the diagram represents the floor plan of a storage facility. Write an expression for the area of the facility in simplified form. Well, area is length times width, so I'm going to multiply those two binomials together. So 5x plus 4 times 4x minus 4. So I'd FOIL that. 5x times 4x is 20x squared. 5x times negative 4 would be negative 20x. 4 times 4x is 16x, and 4 times negative 4 is negative 16. So when I start combining like terms, the only ones I can combine are negative 20x and 16x. So I put those together to get negative 4x. So my final answer should be 20x squared minus 4x minus 16. Here is homework 419. Yes, you only had to do the odds, but all the answers are on the screen. I would personally prefer that these are written as ordered pairs instead of just your numbers to be the true solutions. And this is homework 420. Again, you only had to do the odds, but they're all here. Alrighty, today we're going to talk about simplifying radicals. So radicals are our square root signs. You should have talked about these a little bit last year when you went over Pythagorean theorem. But basically, when you are taking the square root of something, it's basically the opposite of squaring something. So when I take a square root, I'm looking for a number that multiplies to be that number. So this 2 square root 3 is how you would read that. Basically, what that means is 2 times the square root of 3. This radical symbol will operate much like a parenthesis. And so you will assume that any number that is outside of it is going to be its coefficient, and they will be multiplying together. So perfect squares. Y'all, you need to know the perfect squares list through 15. You have to have those memorized. If you don't, you need to go home and memorize them because it will make your life so much easier. So let's go ahead and go through them. 1 squared is 1. 2 squared is 4. 3 squared is 9. Remember, when you are squaring something, that is the number times itself. It is not that number times 2. So 3 times 3 is 9. 4 squared, or 4 times 4, is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. You need to have 1 through 15 memorized. Ideally, you have more than 1 through 15, but you need to have at minimum 1 through 15 memorized. So I would make sure you memorize them if you do not know them. 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. 25 squared is 625, okay? These are the ones you will be dealing with most frequently, especially that list 1 through 15. So if you could go ahead and get those memorized, it will make your life 10 times easier, I promise you. So to simplify a radical, as you can see, we have a whole bunch of numbers with a square root sign on top of them. To simplify a radical, you are looking for numbers that multiply to be the one that is inside the radical. Well, we know that 4 is a perfect square because that's 2 times 2. So the answer for 4, if I simplified that radical, is 2, or the square root of 4 is 2. Now, you're probably thinking, what is that symbol in front of that 2? That symbol is called the plus minus symbol, and you must include that with all of your answers. If you don't, I will take points off. The reason for that is because Well, I'm looking for a number times itself that gets me the number under the square root symbol. Well, 2 times 2 is 4, but -2 times -2, a negative times a negative is still a positive, so -2 times -2 is also 4. Well, now you should start to think, oh, can I have a negative under the square root symbol? You cannot have a negative under the square root symbol without the number becoming imaginary, because we just talked about square roots, we're thinking of a number times itself to get that other number. Well, a negative times a negative is always going to get you a positive, so there should be no negative under the square root symbol. The square root of 16, well, that's 4 times 4, or -4 times -4. So we would write our answer as plus minus 4. Then we have the square root of 25. Well, what multiplies to get 25? We have 5 times 5, or -5 times -5. Again, plus minus. Then we have 100. So what multiplies to get to 100? We have plus minus 10. 10 times 10 is 100. -10 times -10 is 100. And then what multiplies to get 144, or the square root of 144? We're looking at 12 times 12, or -12 times -12, which our answer would just be plus minus 12. So we're going to use that principle, and now we're going to simplify things that are not perfect squares. There is nothing times itself that equals 8. It would be an irrational number, okay? This is one fact that you may not have picked up on, but when you were in 7th grade, when you were talking about Pythagorean theorem, one of the things that you should have learned is anytime you take the square root of something and you end up with a decimal, that number is irrational. The only time that you will get a rational answer when you're dealing with square roots is if you get a whole number or integer answer here. So there is nothing times itself that will equal 8. So what we're going to do is we're going to simplify this as much as possible. So the thing you are looking for is what perfect square multiplies to be 8. Okay, this is why I said it would be really important for you to know your perfect squares through 15. I'm looking at 8. I know that 4 is a perfect square because 2 times 2 is 4, and 4 multiplies into 8. So here is what's going to happen. I'm going to keep everything under the radical sign, right, or under the square root sign, and I know that 4 times 2 is 8. Well, now looking at this, I can see I have a perfect square, so I can simplify this a little bit. Now I can basically break it up and take the square root of 4 and then the square root of 2. Well, the square root of 4 we just talked about is plus minus 2. And then I don't know what the square root of 2 is. It's an irrational number because 2 is not a perfect square. So I leave my answer as plus or minus 2, because that's what the square root of 4 is, times the square root of 2. So I've taken 8 and simplified it as much as possible. You want the smallest number you possibly can get here inside the radical. So I took the square root of 4, that got me plus and minus 2. I left the 2 because I don't want decimals. I don't want to deal with that. I just want to leave as simplified as possible underneath the square root sign. So now I'm looking at 20. Okay, what is the largest perfect square that multiplies to 20? Well, I know 4 goes into 20, and it's 4 times 5, okay? 4 times 5. Is 4 a perfect square? Yes, indeed, it is a perfect square, because 2 times 2 is 4. Is 5 a perfect square? No, 5 is a prime number. There is no number times itself that will equal 5 that is going to be rational. So again, I'm going to split this up. I'm going to take the square root of 4. Well, the square root of 4 is positive 2 or negative 2, so that's plus or minus 2. And then I leave what's left underneath the radical sign. I'm going to leave that 5. So this most simplified form of the square root of 20 is plus or minus 2 times the square root of 5. Remember, when you have a number outside the radical sign, it is meaning multiplication. Okay, this is where your knowledge of perfect squares will make it easier for you. What is the largest perfect square that divides into 32? Well, 4 goes into 32. But 4 times 8, and I already broke 8 apart, so with a 4, so it's got to be more than that. Oh, wait, 16 goes into 32. So what I'm going to do is the square root of 16 times 2, because that is what equals 32. Now I can take the square root of 16 and the square root of 2. Well, the square root of 16 is plus or minus 4. I can't take the square root of 2, so my answer is plus or minus 4 times the square root of 2. Now we move on to 75. Okay, what is the largest perfect square that I know that goes into 75? big hint here, it ends in a 5. I should probably try 25 because that's the perfect square of 5. Well, lucky for me, 25 goes into the square root of 75. So now I have the square root of 25 times 3. So I can take the square roots of those separately. So the square root of 25 is, well, what times itself equals 25? Positive 5 and negative 5. So plus minus 5. I cannot take the square root of 3, so my answer is just plus minus 5 times the square root of 3. Last one we've got here, we have the square root of 40. Okay, I know that 4 goes into the square root of 40. I don't know of anything bigger, so we're going to do 4 times 10. I can take the square root of 4, that's plus or minus 2. There is no perfect square that goes into 10, so I have plus or minus 2 times 10, and that is equal to the square root of 40. Okay, trying it again. I would recommend pausing the video and seeing what you could do here as we go down the list. Okay, 48. We have the largest perfect square that goes into 48 is 16. Again, knowledge of your multiplication facts makes this so much easier. If you are not good with your multiplication facts, I highly recommend you go home and practice them. So I have the square root of 16 times the square root of 3. So I'm going to simplify that further, and we get plus or minus 4 times the square root of 3. Now we have the square root of 80. Again, 16 goes into the square root of 80. The square root of 16 is plus or minus 4. I can't take the square root of 5, so the answer is plus or minus 4 times the square root of 5. 50, the largest perfect square that goes in there, is 25. The square root of 25 is plus or minus 5 times the square root of 2. 125, again, it ends in a 5. You should try and see if 25 goes into it. So 125, I can take the square root with 25 times 5. The square root of 25 is plus or minus 5. I can't take the square root of 5, so I leave it as plus or minus 5 times the square root of 5. 450. Okay, this one's a little bit bigger. It ends in a 0. 25 is probably going to go into it. It does indeed, but there's an even larger one. 225 times 2 will go into it. Now, what if you get stuck? What if I don't know that 225 times 2 goes into 450? That's okay. You can do the square root of 25, but you may have to do the process multiple times. The reason I got to stop at all of these points is because I can't take the square root of 3. But if I had, let's say, the square root of 8 here, I'd have to do the process over and then multiply whatever numbers are outside together, okay? And you'll see that practice on your homework and watch the homework video if you need to. Okay, now we're going to use this principle to help us solve things. Well, like I said earlier, taking the square root is actually doing the opposite of squaring something. So here I have x squared is equal to 50. Well, I want x by itself. So to get rid of squaring something, I'm going to take the square root. And just like when we were solving equations and we undid addition and subtraction, we always did the opposite. That's what I'm doing here. I'm doing the opposite of squaring something by taking the square root. And when solving equations, what I do to one side, I have to do to the other. So here, when I take the square root of x squared, which when you're squaring something and you take the square root, it cancels out. That's how you solve Pythagorean theorem. When you were looking for what c was, you took the square root. That's how you cancel that out. So that just becomes x. I know that 50, if I'm simplifying this and leaving it in radical form, meaning no decimals, you just leave it with the square root symbol. 25 times 2 goes into 50. So when I simplify that, I'm going to get plus or minus 5 times 2, or times the square root of 2 is equal to x. Okay, we're building on the principles we've already learned, and then we're combining it with what we're doing today. Again, here, I want to go ahead and get x by itself, but I have a barrier here. I have to deal with the fact that this parentheses is squared. So to get rid of the square, because I can't do anything while it's squared, I'm going to go ahead and take the square root of both sides. So that'll get rid of the squared. And then 60, what goes into 60? Okay, the largest perfect square that I know that goes into 60, I'm thinking 4. So 4 times 15, the square root of 4 is plus or minus 2. So I get x plus 8 is equal to plus or minus 2 times the square root of 15. Okay, now to get x by itself, you're solving an equation. You want to do the opposite. Well, currently I'm adding 18, so I'm going to go ahead and subtract 18. So I subtract 18 from both sides. Now, plus or minus 2 is being multiplied by the square root of 15. I could even refer to that as plus or minus 2x. 18, that negative 18, does not have a square root of 5 attached to it. So I cannot combine them. So my answer is simply going to be negative 18 plus or minus the square root of, or 2 times the square root of 15. I cannot combine them because that negative 18 doesn't have a square root of 15 attached to it. So we cannot put them together. So I'm just going to leave it as 2 separate quantities. And that is my answer. Okay, you're going to see a lot of this on your homework. This is taking it a step further. Not only am I going to have to simplify the radical, but I'm going to have to simplify the whole expression. So for this first one here, I'm going to start by simplifying the radical or simplifying the square root. I'm thinking to myself, what is the largest perfect square that goes into 20? Well, the largest perfect square that goes into 20 is 4. So I have 4 times 5 underneath the square root symbol. Well, square root of 4 is plus or minus 2, okay? But outside here, I have a number. Well, that number, remember, when it's next to the square root sign, is being multiplied. So when I pull out that 2, that plus or minus 2 from the 4, I have to multiply it by the number that is on the outside. This is what I meant by when you didn't know 225 went into 450. If you had pulled out 25, it would have been okay, but you would have had to multiply later because you would have had to done the simplification multiple times. So 5 times 2 is 10. So I get 4 plus or minus 10 times the square root of 5 all over 4. Well, now looking at this, all of these numbers are even. So I'm going to pull out the greatest common factor of the 3 of those numbers, okay? So we have 4, 10, and 4. Well, they're all even, so I'm going to divide them all by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So my answer here is 2 plus or minus 5 times the square root of 5 all over 2. It's basically like I'm splitting up the division and I'm taking out what I can from all 3 of them. Okay, this next one we have over here. Again, we're going to start by simplifying the radical. What goes into 300 that is a perfect square? It ends in 100, so I'm going to go ahead and say 100 times 3 is 300. Well, what is the square root of 100? Well, the square root of 100 is plus or minus 10. Notice the difference here between the first example and the second example. The first example had a number outside the square root sign. Currently, I don't have a number. Well, really, I have a hidden 1 because 1 times anything is itself. So when I go ahead and pull out that plus or minus 10, I don't have to multiply it times anything like I did here. Now, looking at 12 plus or minus 10 times the square root of 3 all over 8, I can see that the 3 of them, 12, 10, and 8, have a GCF of 2 because they are all even. So I'm going to divide all 3 of these numbers by 2. So I get 6 plus or minus 5 times the square root of 3, all divided by 4, and that is indeed my answer. Okay, you have a CFA on special products. Homework 421 is due Monday. Wildcat Sheet 7 is due on block day.